Okay, so everyone over here, welcome to the next session towards topics, and I am just going to start the new topic in today's class, and the topic is metals. It is the most important topic. So if you talk about MCQs, so this is the most important topic, right? So let's just start with this topic. And also in question answers, a lot of questions are related to this topic in paper 2 as well, and it will help you out in paper 4 as well. So let's start with the reactivity series. Reactivity series. Yes. Any one of you learned this? Yes, Hamza and Asma, are you able to learn this or not?
Not yet.
But you need to learn this first. This is the first thing that you need to learn when you are going to practice chemistry or when you are going to attempt the paper of chemistry. So this is the backbone after periodic table. So you need to learn this. So the very easy way to learn this is sometimes different teachers use a different style to learn this. But I just want to recommend you to remember in this way that first of all, we have group number 1 elements, right? They have 1 electron in the outermost shell, so they are highly reactive, right? And as we move down the group in group number 1, so the reactivity of the metals increases. We learn it in periodic table as well, okay, later on. But you need to remember this: when we move down to the group, the reactivity of group 1 metals increases. That is why we need to place these elements in this way. First, we need to write potassium, then sodium. In fact, we have more than elements than these two. We have rubidium, cesium, francium, and more reactive elements also there in group 1. But in O levels, we just need initial 3 or 4 elements. That's enough for every group. So that is why I'm just having potassium and sodium in the reactivity streams. Even if you want to place rubidium, cesium, francium, rubidium, cesium, francium, they are down the group, but in reactivity they are just like this. So we can place them over here, but right now we don't need this. So that is why we're just using these two. Then definitely when we move towards group number 2, they have 2 electrons in the outermost shell, so they are a little less reactive than first group. And same as when we move down to the group, the reactivity will increases, so we can place them in reversed form. So first calcium, then magnesium. Again, magnesium, calcium, strontium, barium, radium. We have a lot of elements in group 2 as well, but we just need to place these two. In fact, we can place strontium, barium, radium as well, but we just need to place these two, right? Then definitely group number 3, it is one of the other group of metals, and definitely they have 3 electrons in the outermost shell, so they are a little less reactive than group 2, and we just have 1 element in this group, which is aluminum, right? So after that, we have transition metals. Transition metals have variable oxidation states. So how can we learn these metals, because they are too much in transition metals block, but we just need to write 3 of them right now in this step, that are zinc, iron, and lead. We have more transition metals in the reactivity series that are copper, silver, gold, but they are least reactive, right? So this is the reactivity series that you need to learn. And how can we learn this? First of all, you need to remember this word. These 5 are moderate reactive elements, and we need to use this word for these 5. Mazet. I for iron, L for lead, right? So we need to learn this word, the combination of alphabets, which needs to learn by you. In this way, you are going to learn the 5 metals that are moderate reactive, that are between the reactivity space, right? They are in the central part, right? So these 5 are moderate reactive, and these 3 are highly reactive, and these 3 are least reactive, right? So you need to learn the reactivity series in this way. group 1, group 2, group 3, and then transition metals. The first block of 3 elements are highly reactive. They are highly reactive, most reactive, too much reactive, right? And they are moderate reactive. They are just moderate reactive. And the last 3 are least reactive. So these are 3 parts of the reactivity series that you need to learn. If the examiner asks any other element about the periodic table that are not the part of reactivity series, so definitely the examiner will give you hints and something over there by which you can identify the reactivity of that element, right? And right now I am just talking about the reactivity series of metals, not non-metals. So it is only talking about, we are just talking about the left hand side of the periodic table, not the right hand side. Right hand side contain group 5, 6, and 7 that are the actually groups of non-metals. So we are just talking about metals right now. So why they are highly reactive? The first thing that you can ask to me, sir, why they are highly reactive and why they are moderate and why they are least? So the thing is, why we are considering them the highly reactive metals, because they can react with cold water. They can react with cold water, and even they can react with hot water. Definitely when the element can react with cold water, so in fact they can react with hot water as well. And they can also react with dilute acids. That is why we are considering them highly reactive metals, because they can react with anyone else, even the water, and the water is cold and they are going to react, right? Cold water is the very thing that is a very impossible things for the metals. They are going to react with the cold water. ठंडे पानी से reaction कितना मुश्किल काम होगा ना. But if the metal is going to react with ठंडा पानी, then you can imagine that how reactive that was, right? And then if you talk about moderate, so we are just considering them moderate. Why? Because they can only react with hot water. Hot water, definitely we are applying temperature and then they are going to react. In the normal conditions, they are not going to react with cold water, right? So they are reacting with hot water. In fact, some of the metals react with cold water, but it takes time. The reaction is slow, just like rusting. Iron can react with cold water. That means iron can react with air in the presence of water, in the presence of moisture, but it's very, very, very slow reaction. So we are not considering slow reactions right now. We are just talking about the reactions that are the sudden reactions. That, for example, if you put iron into the cold water, so is there any reaction? No, there is no reaction, right? But it will react after a long time. So we are not considering that. Now they can react with dilute acids also. Now, if you talk about a least reactive, so they are just useless in reactions. They are not going to react with hot water, and they're not going to react with cold water. They are not going to react with dilute acids even. So there is no reaction over there. That is why they are least reactive. That is why we are using jewelries made up of silver and gold, because they are least reactive. If we wear them in our ring, in our fingers as a ring, if we wear them in the neck as a necklace, or in the hand as a bracelet, so they are not going to react with our perspiration. They are not going to react with the moisture. They are not going to be rust, because they are least reactive. That is why they are noble metals. They are known as noble metals, because they are not going to react with anything. In fact, they can react with concentrated sulfuric acid or concentrated hydrochloric acid. Concentration or concentrated acids can harm anything, but right now concentrated is not in our syllabus, so we are not talking about that. And definitely if they react with concentrated sulfuric acid or any concentrated acid, they will show a different trend of the reaction. That is not part of our syllabus in O levels. We just talk about the dilute acid right now. Okay, so this is the reactivity series. Different teacher will give you a different feedback to learn this. For example, most of the teachers say a different line for remember this, so you can use in this way. For example, it is just like a silly thing to learn, but you can learn in this way. Kal Nasima ko mazel. Kal Nasima ko mazel copper, silver, gold dega. Okay, you can learn this in this way if you want to. It is a very cheap thing to learn, but you can. It is the easier way to learn. Kal Nasima ko mazel copper, silver, gold dega. You can learn in this way if you want. But I prefer you to learn in this way, that group 1 first in reverse form, then group 2 in reverse form, then group 3, and then transition metals. And you can learn this measure to remember these 3 elements over here, right? Is that right, Bacho?
Yes.
Now it is very important. The reactivity series is too important. You need to remember this. And one more thing, they are highly reactive. These 2 are highly reactive because they can even react with these 3 are highly reactive. They can even react with cold water, and they can even react with hot water, and they can react with dilute acids. Why? For the storage of these metals, we need to use oils, right? We just need to store them in oils. Otherwise, they are not able to stay in the natural atmosphere where we are living. They are going to react with the moisture of the air. So that is why they are highly reactive. They are soft metal. Initial 2 are soft metal, and calcium is from group 2, so it is a little bit harder than group 1 elements, right? So you need to remember these things. Definitely, we are moving towards periodic table in the next few classes, so we will learn about these over there as well. But right now, you need to remember these things. These are very important. Just take a picture of this, Bacho. Just take a picture of this, quick. Done?
Yes.
Now, I'm just going to give you a few more information about reactivity series over here. One element, which is carbon. It is not a metal, but it can form positive form. So you can place carbon between the ma of cell, right? You can put carbon between these 2 elements. After magnesium and aluminum, you can put carbon over here, and you can put hydrogen over here. In fact, it is not also a metal, but it can form a positive charge, so we can put it over here, right, Bacho? Right, Bacho?
Yes.
Now, one more thing you need to understand over here, the elements like potassium, sodium, calcium, magnesium, and aluminum that are above than carbon, can be separated or can be extracted from their salts by electrolysis, by electrolysis of their molten salts, right? These elements, right? Potassium, sodium, calcium, magnesium, aluminum, they can be extracted. If you want to extract them, so you need to use electrolysis of their molten salts. We done electrolysis in few class before, so you need to remember this, that we done electrolysis of aluminum oxide in that topic. In the molten aluminum oxide was treating with the electricity, and in this way aluminum is going to be collect in the bottom, right? So remember that is a part of our syllabus, to separate aluminum by electrolysis, just to identify this information, right? Then we have 3 more elements over here between carbon and hydrogen. So you need to remember this, the elements that are less reactive than carbon. The elements that are less reactive than carbon, they are easily reduced by carbon. They are going to be easily reduced by carbon, and one of the extraction will be here by blast furnace. That is the part of this chapter. We are going to learn this later on. Blast furnace. In the blast furnace, you will see over there that iron oxide, you can see over there, iron oxide can react with carbon monoxide, and in this way, iron going to be separate and carbon dioxide will be formed. So the loss of oxygen is called reduction. The loss of oxygen is called reduction. So you can see that carbon is going to reduce iron because carbon is more reactive. So सारी की सारी ऑक्सीजन छीन लेगा कार्बन ऑक्सीजन से, क्योंकि कार्बन ज्यादा रिएक्टिव है। ठीक है, जो ज्यादा रिएक्टिव होता है वो अपनी तरफ सब कुछ छीन लेता है, ठीक है। तो कार्बन इज मोर रिएक्टिव, सो it will just snatch all the oxygen from the iron, and in this way iron gets reduced by carbon, right? Even all of these, the remaining three also reduced by carbon because they are also less reactive than carbon. You can write that all of these like copper, silver, gold can also be reduced by carbon. But the thing is, copper, silver, gold can also be reduced by hydrogen as well. Reduced by hydrogen as well. Reduced by hydrogen as well, because they are also less reactive than hydrogen. So one of the most important part of your syllabus is copper oxide is treating with what? Hydrogen, and in this way copper is going to be separated and water is going to be formed. It is one of the important. You can see over here, copper is reduced, the loss of oxygen. So it is reduced, and it is reduced by hydrogen. Hydrogen gain electron, right? Oxygen, right? So you can see over here that this is the important part of your reactivity series. You need to understand this. The highly reactive can reduce the less reactive. The highly reactive can reduce the less reactive. So you need to understand this. It is very important. Okay, this is the part of reactivity series. So you need to understand this. And one more thing that we learned in electrolysis, if you remember this, that bacho, the metals that are more reactive than hydrogen, the metals that are more reactive than hydrogen, if you are going to electrolyze, if you are going to electrolyze them in aqueous solutions, if you are going to electrolyze them of their aqueous solutions, so you will see that hydrogen will form at cathode, because we know that always less reactive will move towards cathode first. So you need to remember this, that the hydrogen is less reactive than these elements or these metals. So all the time when you use aqueous solutions in electrolysis, so there is hydrogen which is going to form at cathode, and only these three metals can form metals in electrolysis at cathode if you are using aqueous solutions of them. Okay, this is one of the more one other important part of the reactivity series that you need to understand, right? And then after that, one of the most important reaction is displacement reaction that you need to understand. Definitely we are going to practice it later on, but the thing is, most reactive or more reactive, you can word the more also over here, more reactive metal can displace less reactive metal. You need to remember this. More reactive metal can displace less reactive metal. We have a lot of things over here about this. Like for example, if you have copper sulfate and you are going to react with zinc, so you can see over here zinc is more reactive than copper. So zinc can displace copper from the solution. It will show you the reaction in this way. Copper will be eliminated, right? For example, आपकी क्लास में एक मोटा सा बच्चा है, मोटा सा, और एक है पतला सा बच्चा, एक छोटा सा बच्चा। तो अगर मोटे वाले बच्चे की जगह पर कोई छोटा बच्चा बैठ गया है, तो वो मोटा वाला बच्चा आराम से छोटे वाले बच्चे को निकाल के भाग कर देगा, चलो उठो मेरी जगह से और निकलो यहाँ से, शाबाश। ठीक है, ये बिल्कुल सेम बात यहाँ पर है। जो हाईली रिएक्टिव होता है वो छोटे वाले को आराम से, लेस रिएक्टिव को आराम से निकाल देता है। बट अगर छोटे वाले बच्चे की जगह पर मोटा वाला बैठ गया है, तो छोटे वाले बच्चे की हिम्मत नहीं है कि वो उसको डिस्प्लेस कर सके। फॉर एग्जाम्पल व्हाट आई एम ट्राइंग टू से, अगर आपके पास कॉपर सल्फेट है और आप उसका रिएक्शन करा देते हो सिल्वर के साथ, सो देयर इज नो रिएक्शन बिकॉज सिल्वर इज नॉट एबल टू डिस्प्लेस कॉपर, क्योंकि उसकी इतनी हिम्मत नहीं है। ठीक है बच्चों, is that clear? Fazal, Hamza, Asna?
Yes.
Yes, Hamza, are you there?
Yes, sir, it's clear.
Okay, good. And what about Fizzer? Fizzer, are you there? Okay, so let's talk about a little about metals. What do you know about metals? Starting with Hamza. Yes, Hamza, what do you know about metals?
Sir, metals are good conductors of heat and electricity.
Okay, you are talking about physical properties of metals, right? So you
Yes.
just write the heading of physical properties. So you are saying that metals are a good conductor of electricity. Oh, I just write this spelling of good, wrong. Good conductor of heat and electricity. Very good. I know this. You are well aware about this property. Very good. Do you have any example that you use in your daily life that uh, in in this way that explain this information? Yes, Sandra. Do you have any example
Sir,
that is?
the tawa we use to make roti, that.
Oh, that's good. And what about any other thing?
Sir, for electricity in the wires, we have copper that we use every
Very
day
good.
to charge.
Copper in wires. Very good. And what? Tawa for roti, है ना? I don't
Yeah,
know what
yeah.
is the English word of tawa, but I'm just using tawa. Tawa for roti. Good. Heat. Perfect example. Now let's move towards Asna. Yes, Asna, can you please tell me anything about metals that you know?
They're usually shiny and hard.
Okay, very good. Shiny and hard. Okay, perfect. And Khizar, are you want to join us? You are going to add something over here? Khizar, are you messaging or what? Oh, Khizar not here. Okay, so let's move toward back to the Hamza. Yes, Hamza, any other property?
Sir, physical properties, they're malleable.
Malleable, very good. What is the meaning of malleable? I don't know.
They can be reshaped.
They can be reshaped. Okay, they can be reshaped by the action of force, right?
Yes, sir.
Okay, if we hit them by the hammer, so they can be changed their shape, right? And what about Asna? Do you know any other property, Asna?
I can't think of any other.
Why? Acha, tell me the first one that you told about shiny and hard. आपने कोई मेटल देखा है ऐसा जो shiny भी हो और hard भी हो?
The metal used for pans.
For pans, no, they are not metals. Pans are made up of Teflon, that is a polymer that is not shiny, it is black in color and a dull black color. Have you seen any metal in your whole life of 15 to 17 years? Any metal? Definitely.
Silver.
Sorry,
Silver.
silver, right? Good. And even you saw, I think, gold as well, if I'm not wrong, and
Yes, they're
iron as
both
well, copper
shiny.
as well. Very good. Now listen, if you know that they are hard, so you can say that their melting and boiling point and their densities are high. You can use this information as well, right? And if you know that they are ductile, they are malleable, so you can say that they are ductile as well. They can convert it into thin sheets and wires as well. You can use this information as well, right? So these are the metals properties, the very important and very simple properties. Now let's move towards some other things about metals. Let's talk about group wise metals, right? If you talk about group number 1, if you talk about group number 2, and if you talk about group number 3, they all are metals, right? And then later on we have transition metals as well, right? We have lanthanides and actinides as well, but they are not the part of our syllabus, so we are not talking about this. They have 1 electron in the outermost shell, they have 2 electrons in the outermost shell, they have 3 electrons in the outermost shell, and they have variable oxidation state, right? They may have like they may lose 1 electron or 2 or electron or 3 or 4, more than 3, right? So we are not talking about that. So they have +1 charge when they lost electron, they have +2 charge when they lost electrons, they have +3 charge when they lost electrons. This is the property of metals. They lost electrons, but when they are lost electrons, they can form multiple charges. Iron may be +2 and iron may be +3. Copper may be +1 and copper may be +2 as well. Now it is aluminum +3 and it is like magnesium, calcium, they all are +2, like sodium, potassium, they all are +1, right? So the main property of metals is the loss of electron. The loss of electron. You need to remember this. The loss of electron is the basic property of metals, and they always form positive ions. Okay, this is the basic information of metals, right? They always form positive ions by the loss of electrons. Now, if you have more reactive and if you have less reactive, if you have more reactive and less reactive, both are together. If both are together, so only more reactive can lose electron. More reactive loss electron first. You can say this. Okay, is there any possibility to lose electrons? So the first more reactive will lose electron, and if it will be finished, then the second thing or the second opportunity will be towards less reactive. If the opportunity is only for one metal, so you need to remember this, always more reactive will lose electrons first, right? So you can say that more reactive loss electrons first. Okay, this is the basic definition that you need to remember. Okay, bacho?
Yes.
Now few more important properties that you need to remember, that potassium and sodium, or you can say that the group 1 metals, right? They are soft. They are soft metals. They have extremely low melting point, boiling point, and density. You need to remember this. They are soft, even they can cut by knife. They are just soft, they can cut by knife. Even मैं लैब में काम कर रहा था, तो मुझे अच्छी तरह याद है, मैंने सोडियम मंगाया था लैब में, मुझे उसको कट करना था. I store them in oil because it is highly reactive. So mostly I store that metal in oil just to avoid reaction with moisture. So I just keep that metal in oil. So मैंने उसको निकाला उसमें से बाहर और फिर जो है मुझे उसको कट करना था. ठीक है, मुझे उसको रिएक्शन कराना था because it was a big piece of sodium and I just want a very small amount of sodium. So I was just finding the knife in the overall laboratory, but there is no knife. But I just got one knife जिसके ऊपर धार भी नहीं थी, बिल्कुल बेकार छुरी थी, बहुत जंग लगा हुआ था उस पे. It was completely rusted. बहुत खराब छुरी थी वो. इवन इतनी खराब छुरी से सोडियम कट हो गया था. So you can imagine that how soft the sodium metal is, right? So they are soft metal, such soft metals. And if you remember, or if you just focus anywhere, if you talk about the metals in your rings and the metal in your necklaces and bracelets and in your jewelries, like जो नाक में पहनते हैं और जो कान में पहनते हैं, अगर आपको उसके बारे में पता हो, या if you talk about the rods of iron that are empty, जो बीच में से खाली होती हैं, उनको अगर आप देखें, so if you apply pressure by your hands even, so they are going to be cold, or they are just going to be converted into a different shape. वो मुड़ जाते हैं. ऐसी है ना, कितने सॉफ्ट होते हैं मेटल कि वो आराम से मुड़ जाते हैं. ऐसा क्यों होता है? Because the structure of metals को अगर आप देखें बच्चों, तो it is just like this. Structure जो होता है ना मेटल का, वो इस तरह होता है. They have a layers of atoms together. They have a layers of the same size atoms. They are just aligned in this way. Right? And you need to remember, बच्चों, आपने हमेशा ये बात याद रखनी है कि they are positively charged ions. They are positively charged ions. They are positive charged क्योंकि metals हमेशा positive होते हैं, right? With a sea of electrons. With a sea of electrons. So whenever you talk about the metallic bonding, whenever you talk about the metallic bond, you need to remember this. It is a bond between positive charge and valence electrons. When the valence electrons of one atom got attracted towards the positive charge of the second atom, it is actually what? It is the metallic bond, right? You can see over here, they are valence electrons. We have a lot of electrons over here. There is a sea of electrons. Every atom have, if every atom has only one electron, so just see over here how many atoms are there. So you can imagine for every atom we have a single electron, and if there are two electrons, so you can imagine a sea of electrons is going to be increased. And if you have aluminum, so you can imagine that we have more than like a thrice electrons than atoms, right? You can see over here, this is the structure of any metal. So due to the free electrons, they are going to conduct electricity, and you can see that the metals are strong because they have metallic bond, right? So for example, if you are going to apply pressure, or if you are going to hammer them, so they will slide over each other in this way. For example, if you apply pressure over there, so they will reshape in this way. They will be reshaped in this way. That is why they are soft, because their atoms are slide over each other. When you apply pressure, when you hammer them, and when you apply force on them, they just change their shape. That is why they are malleable. Why? Because they are atoms. They have layers over each other. When you hit them and when you apply the pressure over them, so they just slide over each other. That is why they change their shape. So you can see this. This is the structure, right? You need to remember. और अगर पेपर में आए ना बच्चों, तो आपने इस तरह देखना है. देखो ये एटम्स होते हैं, एटम्स के बीच में थोड़ा सा वो गैप देंगे पेपर में, ठीक है, ताकि वो सी ऑफ इलेक्ट्रॉन्स आपको दिखा सके. तो यू नीड टू रिमेंबर दिस कि वो इलेक्ट्रॉन इस तरह दिखाएंगे, ठीक है, इस तरह. तो इस तरह होगा आपके पास कुछ स्ट्रक्चर मेटल्स का, क्योंकि उन्हें आपको इलेक्ट्रॉन्स भी दिखाने हैं. So it will be like this, right, बच्चों? Is that clear?
Yes.
Now you can take a picture of this. Just do it quick. पहले तो हम इसकी पिक्चर ले लेते हैं. It is the most important thing. इसकी पिक्चर ले लो जल्दी से पहले. अभी हमने जस्ट स्टार्ट किया है, ठीक है ना. अभी हमने कुछ एक्स्ट्रा काम नहीं किया है. अभी हमें बहुत सारी चीजें करनी है. डोंट वरी अबाउट दैट. अभी हमें रिएक्शन वन बाय वन सारे करने हैं. हमें ब्लास्ट फर्नेस करना है, हमें रस्टिंग करनी है, हमें कोरोजन प्रिकॉशंस करनी है. ये हमें बहुत सारी चीजें करनी है. डिस्प्लेसमेंट रिएक्शंस भी करेंगे आप बहुत सारे, बट वी आर जस्ट गोइंग टू रेडी फॉर दैट. हम उसके लिए तैयार हो गए, ठीक है. जस्ट टेक अ पिक्चर ऑफ दिस.
Done.
Just take a picture of this as well. Yes, Sandra, done. Yes, Asna, done.
Yes.
Now we need to we need to keep this in our mind. If we talk about transition metals, so they are a different elements, right? So if you talk about the physical properties of transition elements, physical properties and the chemical properties, they are a lot of different from simple atoms. So they have a very, very high melting point, very, very high boiling point, and they have very high densities. You need to remember these are the physical properties, only physical properties, and the chemical properties are different. And the chemical properties are they form colored compounds in compounds form, not in an elemental form. In compounds form, they are colored. They used as a catalyst, and they have variable oxidation state. These are the chemical properties of transition elements, right? Variable oxidation state. These are the specific properties of transition elements, right? Okay, so you can use this information in this way. For example, if you are going to compare sodium with iron, So it will be like this. Sodium का melting point होता है 80 something, right? It is not accurate. I'm just telling you, and it is more than 1000, right? 1100 like this. और इसका boiling point जो होगा आपके पास, boiling point definitely 80 से ज़्यादा होगा. We are just considering it to 50 degree centigrade. और इसका कितना होगा? For example, 1600 degree centigrade, right? And if you talk about density, so you can use the density as just like 0.8 because they float on the water. That is why they are very less dense, and it is just like 7.2 gram per centimeter cube, just like this. So you can imagine that how the density, melting point and boiling point of these metals are different from each other, right? So you need to remember only for group 1 and is only for transition metal. I am not talking about group 2 and group 3. They are having a little bit more melting and boiling point and more densities as compared to group 1. Group 1 having the very least melting point, boiling point and densities. They can even just float on the surface of water. But if you talk about group 2 elements, so they are not going to float on the surface of water. They are just going to be dipped into the solution because they have a little bit higher densities than water. They are more than 1, right? Is that clear, Bacho? Anything that you want to ask?
No.
Everything clear?
Yes.
Yes, Hamza, is that clear?
Yes, sir.
Any problem?
No, sir, it's good.
Okay, fine. So that's all about from my side today. We are just going to end the topic over here, and kindly send the recording as quick as you can so we can share with the student as well. And just take yourself, stay safe, stay blessed. Allah Hafiz. Hello, Abdullah.